Good evening, dear students. In today's class, we are going to discuss about permanent magnet synchronous machines, how Pmsm is being used in electric vehicles. So in today's video, we are going to see a DT-based approach on how a Pmsm is designed in a smarter way. Previously, we have used DC motors for EV applications, but due to certain disadvantages in DC motors, we have now switched it to Pmsm. So that will be discussed in detail in a DT-based approach by our students. So let's get into the video. Hello everyone. Today we are going to explain the permanent magnet synchronous motor. Permanent magnet synchronous motor is widely used in electric vehicle. It gives a high efficiency and high torque. Because of only theory, we connected it with design thinking. Let's see how engineers design permanent magnet synchronous motors step by step.
In the empathize stage, we first understand the user needs. So, EV users want smooth speed, low noise and longer battery life. So, the motor must be efficient and reliable. So, that's why we use a permanent magnet synchronous motor is preferred over conventional motors.
Next comes the defined stage. Here we clearly state the problem that reduces the energy and improve the performance. We also need the requirements like compact size and the low energy heating. These goals defines the design of an permanent magnet synchronous motor.
Next we move on to the ideal stage. In ideal stage we think about the stator windings and also better permanent magnets and also for the cooling methods. We also compare the rotor shapes and also cooling methods. Finally, we design the best design for the maximum efficiency.
After ideation, the next is prototype stage. A small Pmsm model is assembled with stator coils, magnet and controller. We check torque, speed and power output. This helps us to check whether the design works practically.
The final step, testing. Finally, we test the motor under real road conditions. We measure temperature, efficiency and the stability. If problem occurs, we redesign and improve again. So, by using the design thinking, we create better and smarter permanent magnet synchronous motor.
Based on today's topic that we have discussed so far, let's conduct a quiz. Okay? So I will be asking the question. The one who knows the answer can come and get the chocolates from me and write on the board. Okay? So the quiz will be on what am I. Based on the parts of the Pmsm, we'll be having this quiz. Okay? So let's start it. First, I hold strong permanent magnets inside me. I rotate when the magnetic field pulls me. What am I? Yes, the answer is rotor. Good. Because the rotor of a Pmsm is a permanent magnet. Okay. Then the second question. I contain three phase windings A, B and C. I create the rotating magnetic field of a Pmsm. Now, I convert DC from battery into three-phase AC. I control motor speed and direction. What am I? Yes, the answer is inverter. That will be used for converting DC power into AC. Then fourth question. I store electrical energy for the whole system and without me nothing will start. What am I? The answer is battery, which powers the entire unit. Good. Next, I transfer mechanical power to wheels or loads. I deliver the useful output work. Who am I? shaft. The last question. I remove heat and keep the motor cool. I protect the system from overheating. What am I? Yes, the answer is cooling systems or cooling fans. So that is the end of the quiz. So thank you for participating in this DT based approach of PMSM and also in the quiz. Thank you. Good evening.